Today we're here because Istvan Hargittai is visiting for a couple days, and he's going to give a talk about, the flyer's not up there anymore, Edward Teller and the other Martians of science, all of whom we've heard about during our lives and our careers. I met Istvan at George Washington University last year when he gave a similar talk to the faculty at GW. And I was impressed then about the depth of his knowledge of Edward Teller, and he was just mentioning a few of the other people along the way, but also his scholarship. Because for a practicing research scientist, I just couldn't imagine how he was able to come up with all the details and all the knowledge about these people, and then give a very literate talk about their life and career. I've since found out how he's come up about this. He has put together a 6-volume set of interviews. They're called Candid Science Conversations with Great Scientists, Nobel laureates, Wolf Prize winners, and the like. 6 volumes, 36 of these conversations per volume. You can do the math. We're more than 200 of these interviews. And Norman Ramsey, in fact, was one of the interviews. So he learned a lot about scientists and creativity and what motivates scientists to make their discoveries. Yesterday, some of us heard him talk about The Road to the Nobel Prize by Danny Shechtman's Nobel Prize, whom he knows personally. And it was a little bit about how you identify a discovery and how you run with it once you've made that discovery. And today we're going to hear about 4 or 5 other people who also made important impacts in science and in society. Istvan is a research scientist by training. Yesterday, he said he's not a historian, but I come to correct that. He has become a historian, not by training, but by his contributions. He's at the Budapest Technical University, where he's a member of the General and Analytical Chemistry Institute. Part-time, he's also the head of the Hungarian Academy of Sciences Department of Structural Chemistry at oeuvres University in Budapest. oeuvres is the largest university in Hungary. That's where he got his PhD from. He's also got a Doctor of Science degree from the Hungarian Academy of Sciences. Got a number of honorary degrees from Moscow State University, from the Russian Academy of Sciences, and also from the University of North Carolina at Wilmington. He's also spent a lot of time in the United States and other countries as a visiting scientist. He's been, for example, at Cold Spring Harbor, University of Connecticut, University of Wilmington, North Carolina, Cambridge, and University of Texas at Austin. But he's not going to talk about his research today or even yesterday. He's talking about this history of science. And I've already mentioned the 6-volume set. From that set, he's also parlayed another couple books. One of them is called The DNA Doctor, which is candid conversations with James Watson. Another one is The Road to Stockholm. A third one, which just came out, and in fact we have not the books, but the flyers over here. Yeah, it's called Driving Curiosity. Driving Curiosity, What Fuels the Passion of Science. That's a new book. You'll have to get that one from the local bookstores, if you can find one. What he's going to talk about today is the Martians of science, and in particular Edward Teller. We did order some books on those two books. They're out there if you'd like to look at them and have a look and maybe have them signed afterwards by Istvan. But we're glad that you could visit us again. The first visit was in the 1970s with Dave Lyde. And you're back again talking not about your hobby, I would say, it's more than a hobby now. I would say your avocation. So would you join me in welcoming Istvan Hargittai?
Thank you very much. Does this work? Back there. Okay. Thank you, Bill, and yes, just a second. Thank you, Bill, for the introduction, and thank you for the invitation. Bill attended my talk at GW University this year, in April, and to me, this was a good sign that he liked the talk when he invited me to come here. So I was doubly glad about that. And I'm quite moved to have this opportunity to be at NIST, a famous research institution. And I'm going to talk about truly one of my favorite topics, Edward Teller and the other Martians of science. This is part of history and part of science history today. Months ago, I gave a similar talk in India, and I understood there, more than anywhere else so far, that it is also part of our present problems to consider the fact that we are living in a nuclear age, and we may have to worry about that. The day before yesterday, I was at Stanford University and I attended a talk by William Perry, who used to be a defense secretary in the United States, and he talked about making the world nuclear free. But I think it is no longer so simple that if the United States and the Soviet Union, which no longer exists, would decide to become nuclear free, there are other forces around that may not follow suit. And I think it's not so unambiguous anymore that disarmament is the only way to go. I'm myself surprised how conservative I'm sounding. But today I'm talking about the 5 Martians. And first, the name that many of you, I'm sure, know, that it came from a conversation between Enrico Fermi and Leo Szilard. Fermi was wondering how did it happen that so many Hungarians were participants in the Manhattan Project. So many Hungarians came out so gifted from Hungary, and Leo Szilard said, well, we are not Hungarians, we are Martians, we are just camouflaging ourselves and using the Hungarian language. But the definition of a Martian is that these were great scientists who were willing to risk their scientific careers and wanted to defend the United States and the free world from the Nazis and then later from communism. And this is important to give this definition because lately this label of Martians have become diluted, and some authors have used this label for anybody who came out of Hungary and made a career in the West. I'm going to give just a glimpse into these 5 lives and then focus more on Edward Teller's life and career. But I would also like to say that these Martians didn't just leave Hungary because they were interested in learning what is in Western Europe and later in the United States. They were forced out of Hungary because they were Jewish and they didn't see any career for themselves. They may have not foreseen what worse would later come. And then they were forced out of Europe when the Nazis came to power in 1933 and came to the United States which welcomed them. And all of them, in different ways, participated in the Manhattan Project. Theodor von Kármán was not directly involved, but he was very much involved as advisor to the Air Force of the US Army during the Second World War. As you know, there was no separate Air Force of the United States. It formed only after the Second World War, when he again became a very important advisor to the US Air Force at that time. But the other four were directly involved with the Manhattan Project. And when years ago I visited Hiroshima, I was wondering whether the fact that I came from Hungary would color the attitude of my hosts in Hiroshima, since it is known that so many Hungarian physicists participated in the Manhattan Project, and I found a very, very friendly attitude toward me, because they clearly distinguished between science and between what war may bring onto people. And in addition to that very famous war memorial, there is also another memorial in Hiroshima which commemorates Einstein's equation. And that also shows that they distinguish between the two. I'm showing there up there Ed Westcott's photograph of a poster which at least one of the reasons for the bombing illustrates. That it was important the atomic bombs were important in finishing the war quickly and with the least amount of sacrifice, even though it was a heavy sacrifice. So 4 of the 5 Martians were very conservative. They advocated a very tough stand toward the Soviet Union, and Theodor von Kármán was one of them. Leo Szilard's most important act in this was that he asked Albert Einstein to sign a letter to President Roosevelt in 1939, which eventually led to the Manhattan Project. This picture is from reenacting the scene after the war. Eugene Wigner, with whom I started correspondence back in my student years, and then I met him in 1969 at Austin, Texas, was the world's first nuclear engineer. Of course, we know him as a theoretical physicist, but he started as a chemical engineer. In fact, almost all of the Martians got their education, including von Neumann, who is known as a mathematician, in chemical engineering, because at the time when they were growing up, to become a physicist or a mathematician didn't have very good job prospects, but chemical engineering was. And also young people listened to their parents more than perhaps today, and the parents wouldn't let them study just pure physics or mathematics. They had to study chemical engineering, and for Wigner, this served very well, because in the Manhattan Project, especially since he was involved with nuclear reactors, knowing materials was a very important ingredient in his work with engineers. Later, he promoted civil defense. Eventually, he didn't play a very important role after the Second World War, especially in later years. John von Neumann, sometimes he's called the father of the computer, which is not quite accurate. He was the father of the stored program computer. And of course that was important, and that was used both for the atomic bomb project and for the hydrogen bomb project. And then we come to Edward Teller. Now, I wrote a book about the Martians of science, which appeared first in 2006 and was then published in paperback in 2007. It has been very successful, but I also got the experience, not just an impression, that out of the 5, Teller was extremely controversial. I grew up in a society where things were either black or white, very contrasted, and whenever I came to the United States, it always attracted me how tolerant people were in the United States. And this is true except when Teller came up into the conversation. People either hate him or adore him. And I thought that I will try to produce an objective biography of Edward Teller, and this is the result of this. So when we talk about Teller, it's a question whether he's a savior or a villain, and I think he was both. We cannot say he was neither, he was both. He was an important scientist. He did a lot of very useful things for reactor safety. He was the father of the American hydrogen bomb. See, I'm hesitating a little bit whether to say he was the father of the hydrogen bomb or the American hydrogen bomb. To this day, this is not 100% clear whether the American hydrogen bomb had an influence on how the Soviets produced their hydrogen bomb. Whether there was intelligence involved, like in the case of the atomic bomb or not. He initiated Livermore. He was an adversary of Robert Oppenheimer. That could be a whole other topic. He opposed the test bans, and then he promoted SDI. And I'm going to discuss some of these questions, not all of them. First, I'd like to show you Teller as a young student, and he was a student of the same university where I am from, Budapest Technical University, which is called now Budapest University of Technology and Economics. And he was a student of chemical engineering, but he took, in addition, subjects that were unusual for a chemical engineering student, like vector analysis and theory of relativity. Teller started his studies in Budapest because there was a debate in his family. His mother didn't want him to leave Hungary, and his father was convinced that he had to leave Hungary if he wanted to make a career. And of course, he was right, but the compromise was that Teller would be staying in Hungary until he reached 18 years of age. He graduated from his high school when he was 17, so he started his university studies in Budapest, and then in January, when he became 18, he left this university and left Hungary and went to Karlsruhe, and then from Karlsruhe to Munich, and then from Munich to Leipzig. And in Leipzig, he did his doctoral studies under Werner Heisenberg. At that time, you could do the doctorate without a master's degree, which over there is called the diploma work, not in chemistry, but in physics. Because again, physics was not an official profession at that time, not only in Germany or in Europe, but in the United States either. Charles Townes writes about this, and he came a few years later that he didn't know in his youth that physics was a profession. So this is what happened. He prepared his doctoral thesis under Heisenberg, defended it, and got his doctorate in 1930, which means that he was 22, a young doctor, and he really made it his way into the top circle of scientists in Europe. And this I'm telling for the younger generation that at that time, German was the most important language in science. And American scientists, if they wanted to become really part of the elite circle of scientists, went to study in Germany, had to learn German language. This was all over in 1933. But in 1930, this was the Mecca of physics, Leipzig and Göttingen and Berlin. So first, Teller stayed in Leipzig as Friedrich Hund's assistant, and then he moved to Göttingen, where he was invited. We would call this today as a postdoc, but he just worked as an assistant for other famous physicists like Max Born and James Franck and others also. He was already very active in building up cooperations with other scientists. But then he had to leave Germany in 1933. Technically, he didn't have to leave because he had a Hungarian passport. And, for example, Lisa Meitner, who had an Austrian passport, stayed in Germany. Later, she regretted it very much, but she left only after the Anschluss, after 1938. But Teller left at once, and all the other Hungarians, all of them first went to Germany, left Germany in 1933 or even before. So Teller went to Copenhagen for roughly a year, then to London for roughly another year, and then in 1935 he got an invitation. In 1935 he was 27 to become full professor of physics at George Washington University in Washington, D.C. And this invitation was engineered by George Gamow, whom he had known already in Europe. They cooperated and they built up a very good interaction also at George Washington University. Now, I'm showing here a picture of a group of scientists. Teller is on the second row, third from the left, very modestly, but look at this collection. I'm showing only the first row, and there are back also scientists who became Nobel laureates. It's just a fantastic. I'm showing this picture to indicate how much Teller was part of this group of physicists. And some glimpses into his life, very briefly, just that we get to know him a little bit better. I will single out three features. One is, let's look at the picture on the left. There is Landau, Lev Landau, and then George Gamow, and then Edward Teller on the skis. And this is significant that he's on the skis because this picture is from 1934 when he was in Copenhagen. And in 1928, in Munich, he had an accident with a tram which cut off his right foot. And for the rest of his life, he used a prosthesis. And he never gave other people any feeling that he was an invalid. He had to undergo several operations, and he had a lot of pains during the recuperation, and he felt that the painkillers were interfering with his thinking, and at one point he decided not to take any more painkiller. He swallowed some water and told himself, now I took a painkiller, which he didn't. And he forced himself to move the pain away. He had a very, very strong willpower. The middle picture is Arthur Koestler, who could be considered as an honorary Martian. He wrote probably the most important political novel of the 20th century, Darkness at Noon, and Teller credited Darkness at Noon with his having become an anti-communist. I'm not sure that this is accurate, and in different accounts he mentioned other influences. But it was a very important and very influential book. Koestler wrote about these staged trials in the Soviet Union, and while I don't think that this was 100% what made Teller into an anti-communist, because I think Teller's anti-communism was more political than ideological. Teller viewed the Soviet Union not just as an alien ideology, but as a threat to the security of the United States and the free world, mainly this one, and eventually he also wanted to get projects for Livermore, for the Livermore laboratory. And that was another source of his very, very strong anti-communist, anti-Soviet stand. And finally, I turn attention to Maria Göppert-Mayer, who later became a Nobel laureate physicist. Teller, for some years, was completely infatuated with Maria Göppert-Mayer. Very few people know about this. They had a correspondence, and Teller begged her to destroy his letters to her. She never did, and then his letters were discovered. And it's like a secondary school, a high school student writing to his sweetheart. Everything remained platonic, but it shows a side of Edward Teller that we would have never associated with his personality. So the war happened, and then after the war, there was a meeting of theoretical physicists. He was still in the midst of other great scientists. This was in 1947. I listed the names up there. It's just a fantastic collection of scientists. This meeting was on Shelter Island in an inn, and just so that we stay on the ground of reality, I also quoted, there was a sign on the wall of this inn saying restricted clientele, meaning that no Jews were welcome. And of course these were war heroes because they built the atomic bomb, so they were admitted. But even in 1947, I write about this in my book, and my editor at Prometheus didn't want to believe that this happened. This is so little known that such discrimination could have still existed in the United States in 1947. It doesn't exist anymore as far as I know, but the situation was very complex. It was also complex because, as Albert Einstein recognized, nuclear weapons changed the international relationships. He recognized that international interactions will never be the same again, having nuclear weapons around. And eventually, when the policy of mutually assured destruction came to life, Albert Einstein's prediction was realized as it was valid. This is a Hungarian graphic artist friend of mine made this drawing, two scorpions killing each other. One cannot kill the other without getting killed by the other. And this is after Robert Oppenheimer saying that the two superpowers are like such two scorpions. So the international situation was completely changed, and this brings us to this famous debate in 1949 whether the United States should develop the hydrogen bomb or not. And there was the General Advisory Committee advising the US Atomic Energy Commission whether such a development should take place or not, and the General Advisory Committee, which consisted of scientists primarily, took a stand that the United States should not develop the hydrogen bomb. There was a majority opinion and a minority opinion. The majority opinion, Oppenheimer and others, said that the United States should set an example. The minority opinion, Fermi and Rabi, said that the United States should make a solemn pledge not to develop this kind of weapons. This was 1949, and we now know that in the Soviet Union, the development of the hydrogen bomb started in 1946, started before they would have produced the atomic bomb. So the American side was not well informed about this. And even today, we very often meet such opinions that the hydrogen bomb shouldn't have been developed, Teller was to blame. But it shouldn't be ignored that for the balance of power, both sides should have had this weapon. And Leo Szilard is usually considered to be the opposite of all the other Martians for his politics, but even he credited Teller. He said that the United States might have missed out on the hydrogen bomb had it not been for Edward Teller. And this is a very little known statement by Szilard, but he made this statement in a lecture at a meeting of the Friends of Brandeis University, and it is very well documented. And Szilard, in his usual way, he gives an interesting story, which I don't have time to tell now. But the development of the hydrogen bomb started, and of course, once President Truman declared that it should be developed, everybody who was involved realized that they didn't know how to develop it. And it fell primarily on Teller to worry about this, because other people like Hans Bethe hoped that it would not be possible to develop. That might have been a good thing also, because then neither side would have developed the hydrogen bomb if it had proved impossible. But if it was possible, and if they just couldn't find the solution, that was very much worrying Teller and the others. And eventually, and this is what I think is a very interesting thing, again, that Teller could stay creative under such terrible pressure, under such tension. And building on Stanislav Ulam's suggestion, Teller then came to the idea of radiation implosion, and then Richard Garvin made the blueprint, and the first thermonuclear explosion was executed on the 1st of November 1952. It was called Mike, and here is a person, and you see this whole construction on the picture, and it was even larger than this picture shows, was the first thermonuclear device. And it exploded, and it was very successful, and eventually, of course, there were bombs built that could be delivered, and both superpowers did that. When I talked with Teller, and then we corresponded a lot until the very end of his life, he told me that he was more proud of having established Livermore than the hydrogen bomb. And of course, it was together with Ernest Lawrence that they initiated Livermore. And I'm showing here a picture which was taken in Berkeley in '57. By then, Livermore had been established, but it was, for a while, it was just as a subsidiary of the Berkeley laboratory. And again, Teller is in a good company, but it's a small company, because by this time, the Oppenheimer hearing had happened in 1954, after which he lost the friendship of most of the scientific community. The Oppenheimer hearing was a turning point in his life. And one of his friends, President Reagan's science advisor, wrote to me, Edward understood power. He could have written The Prince, Machiavelli's famous book. So he was a Machiavellian, even according to one of his friends. Now imagine what his enemies thought about him. So he lost his friends, most of the friends. He went into a third exile. First he went into an exile from Hungary, then from Europe, and this was the third exile, and this was the most painful exile for him, because this cut off his lifeline. He did not create alone. He was always creative in the company of one, maybe two colleagues, but almost never alone. And after '54, he had seldom had opportunities to cooperate with other scientists. So his scientific production went down very, very sharply. Instead of scientific peers, he became a member of the military and the political leadership, and for him that was very bad, not only because he lost his creativity, but also because he lost the medium which could be critical of his lots of ideas. The military leaders and the political leaders were no match to his intellect. So those debates, criticism stopped exercising their useful function on him. But let's go back to the hydrogen bomb. Both superpowers developed it, and both fathers of the hydrogen bombs had a similar reasoning. Sakharov thought it was necessary to balance the challenge by the United States, and Teller wanted to avoid learning the Russian language. And Ginsburg, Vitaly Ginsburg, he didn't have clearance to the Soviet nuclear project, but initially he could contribute to the project. The reason was that his wife was in exile, ostensibly for an anti-Stalin plot, and so he didn't have clearance. Eventually he lost even his access to the project at all. He couldn't even look at his own notes anymore. But he is credited to, the Russians called the three basic ideas of creating the hydrogen bomb, the first and the third. Now we know what those ideas were, but I'm not going to discuss this because this is not our purpose today. The first and third belong to Sakharov, and Ginsburg suggested the second one. And he also considered at that time a patriotic duty to work for the nuclear weapons of the Soviet Union. The Soviet Union was just through a terrible war against the Nazis, and there was a widespread feeling that another attack might be coming from the United States. Eventually, of course, Ginsburg and everybody else understood that it would have been a tremendous tragedy if Hitler and then later Stalin would have possessed first the nuclear weapons. A few words about Sakharov, because sometimes people ask whether Teller might have become the American Sakharov or was Sakharov the Soviet Teller. I don't think they had very much in common. Sakharov was a devoted Stalinist. That's important to state because we all consider Sakharov our hero, but I think if we know him better, we can worship him even more, because he had the strength to make a change in his views. So he was a devoted Stalinist. And then he started looking into the nuclear tests and found them very hazardous for people's lives and for the next generation. And after a very successful test, when the Soviet leadership received the Soviet scientists, he gave a toast, and Sakharov said, in the presence of Khrushchev and the other leaders, that may our tests be successful always on testing sites and never over cities. And Khrushchev became very upset, very agitated, and humiliated Sakharov publicly. He said, just stick to your science and don't interfere with politics. And that was a big change for Sakharov. He understood his place and he didn't like it, and we know eventually how important he became as a human rights activist. I don't think Teller would have been like that. And I can discuss that also, why I'm just saying this without elaborating, but I have to move on. Teller was very influential in the United States. Actually, he was very influential in the Soviet Union also. I almost misspoke. But not only with Republican presidents, but even with Democratic presidents, not because they liked him, but because they knew they had to take his opinion into account. President Kennedy especially didn't like Teller, but couldn't ignore him. Teller started out, as most of the immigrants in this country as a Democrat. Then he switched and became a Republican. And here we can see not only important government people, but important scientists also, Glenn Seaborg and Edwin Macmillan. And obviously, Teller was important for Kennedy. And whether Teller's importance is overestimated or not, I also have an opinion about this, but I would like to move on. Teller talked about the fallout a lot of time, and usually he belittled the importance of fallout, the consequences of testing. He made ridiculous claims about how little danger it represented. But then, if circumstances required, he could admit that there may be birth defects as a consequence of testing, but he said this is just a small price to pay for testing. And this particular statement, which is in one of his books, so this is not just a casual statement, I think this was, in my eyes, the lowest point in his career. But there were several low points, of course. President Eisenhower, in his farewell speech in 1961, January 1961, made a very famous statement about the influence of the military-industrial complex. That is very often quoted. Now I'm quoting another part of his speech about the influence of the scientific technological elite. And I think this could have been, and maybe it was, directed toward Teller, because Teller was such a person who thought that once there is a solution by technology, we got the solution and we should go for it. And he thought that political and sociological considerations could be ignored. And then the next thing I would like to mention is SDI, again, just in passing. But again, I'm showing a parallel between the Soviet approach and the American approach, and I find them very similar to each other. Actually, the Soviets pioneered this approach that anti-missile system is to save lives rather than anything else. And then President Reagan said, wouldn't it be better to save lives than avenge them, in his famous March 1983 speech, in which he declared SDI. And President Reagan advocated a nuclear-free missile defense. And somehow Edward Teller could convince the American leadership to build this X-ray laser system for missile defense, which was not nuclear-free, but somehow it escaped the attention of the political leadership. And we know that for years this was going on and didn't work, and then he came up with, he was no longer generating these ideas, but he was promoting them. They came up with the brilliant pebbles idea, which didn't work either. And in this I'm reminded of, and this is very devastating from my point of view, of the Soviet charlatan scientist Lysenko, who always promised the Soviet leadership that in a few years' time the Soviet agriculture would be lifted if only they would follow his advice. He never said next year, he never said in 15 years, always a few years, 3, 4, 5 years. And this is what Teller did also. And in this sense, he misled the American leadership. But of course, there had to be a leadership which was willing to be misled. And a few words about the scientists' responsibilities. Teller got a lesson from Oppenheimer in 1945. Leo Szilard engineered a petition to the American president that the atomic bombs should be demonstrated, should not be dropped without warning, and various other solutions, and Teller was hesitating whether to sign it or not. And here comes another example of what I followed through using several examples. That Teller, whom we know as a very self-assured, very aggressive person, always sought the approval of his superiors. So in Los Alamos, his superior was Oppenheimer, and he went to see Oppenheimer, and Oppenheimer talked him out of signing the petition, saying that the political leaders know and have a broader picture, which is true, and was true in this case also. So Teller didn't sign it, returned the petition to Szilard with an explanation. Later he developed this version of his history that he opposed the atomic bombs, which was not true, but many people believe because he wrote about and spoke about it repeatedly. And Khrushchev said the same to Sakharov. And Teller said the same to all scientists repeatedly: make your discoveries, but don't try to influence how society would use your discoveries. Leave it to the elected representatives. And he didn't follow his own maxim at all. This picture is from 1987, but first I would like to say a few words about 1986. There was this famous meeting in Reykjavik about two things. One is nuclear disarmament, and the second about restricting SDI to the laboratory. The Soviet president, Gorbachev, suggested nuclear disarmament if the United States would restrict SDI to the laboratory. And this is so vague as anything like that can be, because nobody ever defined what laboratory meant. Was it a building? Was it the Earth? Was it the universe? We shouldn't be surprised, because there were plans to cheat on the test ban, to send rockets on the other side of the moon and make the explosions there, and then another rocket would be monitoring things, so nobody would notice. There's all kinds of crazy things, but it's not so crazy. So 1986, President Reagan refused this because he was enamored with SDI. And so was Gorbachev, because he was so afraid of SDI. The Soviet scientists were not too much afraid of SDI because they knew it couldn't be accomplished, especially not in such a time frame. But the Soviet leadership was very apprehensive, because they knew that by then, by the mid-1980s, the Soviet Union was no match to the United States in computerization, miniaturization, high technology, and they could not have built a similar system. So no agreement was reached in Reykjavik in 1986, but in 1987, there was a small agreement about some disarmament. That was more realistic, and President Reagan gave a big reception in the White House at the end of 1987. The cream of American society was invited, and the scientists were represented by Edward Teller. That was a receiving line, and President Reagan introduced Edward Teller to President Gorbachev. This is Edward Teller, and Teller stretched out his hand. Gorbachev wouldn't take it. Reagan thought that he didn't hear. This is the famous Edward Teller. Gorbachev still remained unmoved, and Teller walked away. First he felt humiliated, and then he felt infinitely proud, because if the Soviet president recognized him by this really impolite behavior, then he must have been very important for the Soviet leadership. Now, there is only one problem with this story, which is, you can read it in his memoirs. It didn't happen. The American media reported every minutest detail about this White House reception. Couldn't find anything. Everything. Usually, as they report, the dresses, the dishes, everything. And I read everything what I could about that reception. No mention of this very interesting incident. Then I wrote asking former Secretary of State, who was the Secretary of State at that time, sitting at this reception, George Shultz, and he didn't know about such an incident. I wrote to President Gorbachev also, but he didn't bother to respond. So, and Teller's life was marred by these missing handshakes. Because after the Oppenheimer hearing, he went to Los Alamos next time, and people wouldn't shake his hand. That was real, and that signified his third exile. So I'm also telling you this story because if you read his memoirs, it's a very entertaining book, but we have to be careful with what it says. So I came to the conclusion of my talk. I listed here positive and negative things about Edward Teller, and I didn't discuss all of these. He was a great scientist, and we could talk about that also. He did a lot for nuclear safety, and as I understand, if Fukushima followed his prescription for how safe a reactor could be built, the tragedy might have not happened. He was instrumental in developing the American hydrogen bomb, and this is a matter of contention, I know, but I think that the fact that both superpowers possessed the hydrogen bomb contributed to maintaining peace for decades. He initiated Livermore. Again, here we cannot imagine how without Livermore the American defense would have developed. We cannot make a test experiment. And then about SDI, I distinguish between two things. I think SDI brought a dividend because it made the Soviet Union uncertain and unstable, the leadership especially. But it was not feasible. So feasibility, from the point of view of feasibility, it was a negative deed, and I think that Teller, as I said, misled the leadership, and it was not the only time. President Eisenhower, who was especially good in listening to scientists, not all presidents have had that, took Teller's word for the possibility of a clean bomb. I remember having read about President Eisenhower making a statement in a press conference that we are going there, we are already at about 95% clean hydrogen bomb. So it was only 5% missing. But for any hydrogen bomb, an atomic bomb must be used. So it cannot be clean completely. And this, the scientists somehow forgot to tell the American president. So this was not the first time that Teller behaved in such a misleading way. And when he was accused by his colleagues, he said, "Oh, I'm an incorrigible optimist." But that optimism was very costly. What I find very negative was his personal bias. His personal bias not only when he destroyed others, but even when he praised others, his personal bias worked very strongly. For example, he idolized Heisenberg. Heisenberg was the head of the German atomic bomb project, and which failed, we know. And Teller said and wrote that this was because Heisenberg sabotaged, because Heisenberg didn't want to give Hitler an atomic bomb. And this is not what the real story was. The Nazi leaders were not interested in nuclear weapons because they wanted a blitzkrieg. They thought that the war would be over before such bombs could be built. And they were not pushing the scientists. And the scientists were laboring on the atomic bomb in Germany in spite of this disinterestedness of the Nazi leaders. But for Teller, Heisenberg was a hero. Heisenberg was no hero. Heisenberg made very questionable visits to other countries under German occupation, not only to Denmark, which is so well known. And he had very despicable acts, which are now very well documented. But Teller wouldn't hear of that. For Teller, Heisenberg was a hero, and Teller didn't see Heisenberg, didn't communicate with him between 1933 and 1945, so he couldn't know anything about it, but he maintained this stand. He belittled fallout, and when he didn't, then we have seen what he thought, as he was opposing test bans, and he misused secrecy. Now, this is another complex matter about Teller. He wanted to eliminate secrecy, except some very important cases like the US shouldn't publicize the trajectories of the submarines. But otherwise, it should eliminate secrecy, which would have been the right step, because many scientists refrained from working on secret projects in the United States. Not in the Soviet Union, because almost everything was secret there, so it didn't matter there, but in the US it did. But then Teller was capable of misusing secrecy, like having a public debate with another scientist, and he had to resort to telling the other one, oh, you are wrong, I am right, but I can't tell you because it's classified. And some people even stood up and left the podium when he said that, because this was not a way of a meaningful debate. So Teller was a very complex character, and we'll have to live with this very complex memory of Teller. People have asked me at the end, after this book, now, is he a hero or is he a villain? And I maintain that he is both. Thank you very much.